No, we're not going to. Yeah. Okay, so we've learned that when we multiply radicals, square root of 3 times the square root of 15, right? What do we do when we multiply? Just bring them together, right? Bring it together. So that's the square root of 3 times 15, and then what do we do from there? Factor it down, right? Everybody with me?
Yes.
So this is the square root of 3 times 5. Then we can take our 3's out, and we get 3 root 5. So that was multiplication. Want to look at another one of those?
Yes.
Since a lot of you were still getting your books out and stuff. Let's look at the square root of 27 times the square root of 2. So what do? Bring them together, right? Bring them together. So we have the square root of 27 times 2. Ronnie, what do I do now? Hello? What do we do? What do we do? What do we do? Brooke, what do we do? Say again? Take apart the 27. Yeah. So my first thought is 9 times 3, right? Okay. So can't take anything out of that, right? I don't have any pairs. So what can I do now? Take there to 9. 9 is 3 times 3. Now I've got a pair. They come out. And we have 3 outside. And inside I have 3 times 2, which means I have 3 root 6. Boom. We're done. You do a happy dance. Woo, I got it right. Right? Oh, I made myself dizzy. Okay. Ready? Got that?
Yes.
Okay. Division. So the only thing I'm going to test you on division is pretty straightforward problems like 3 over root 5. Allie, how do I take care of that one? Remember, move. It could be like the cow math. Move and remove. Move and remove. What's that mean?
You take the bottom one.
Uh-huh. Move it. You move it on top, yes. And then on the bottom, you remove that radical. So it just becomes 5. Okay? You all look very, very excited about this. Let's do 5 over radical 10. Caroline, what do we do with that one?
You move the radical 10 to the top.
Good.
And then you take off the...
Yeah, we remove the radical. Okay, Caden, can I do anything else? Sure, we can reduce the 5 and 10. So 5 goes into 5 once, so it just leaves me with root 10 up top. 5 goes into 10 twice. Remember, you can only simplify if they are both outside or if they're both inside. For instance, let's say that we have 3 root, what do I want to do? 3 root 5 over root 10. Okay. In this case, this is something unique. These are both inside. We know what 5 over 10 reduces to, don't we? That reduces to 1 over 2. 5 over 10 reduces to 1 over 2. What's the square root of 1? What's the square root of 1?
1.
Thank you. So now I've got that. Now I just have to do the move and remove. So what does this become? 3 radical 2 over 2. And there's our answer. Okay. Okay. So that's all review. Today, let's look at adding and subtracting. So if I have the square root of 5 plus 3 square root of 5, what does that equal? How many square root of 5s do I have?
Wait.
Okay, what does 3 square root of 5 mean? That means I have 3 of these, right? That's what multiplication means. You probably forget this because you learned it in like 2nd or 3rd grade when you have times, right? 3 times 2 means I have a 2 3 times, right? 3 times 2. This is what you learned when you first learned about multiplication in elementary school. 3 times 2 means I have that 2 3 times. That's what that means. So how many root 5s do I have? 1, 2, 3. I have 3. Oops. I have 3 of them right there. Plus, I have another one here. So how many total root 5s do I have? Oops, this is a plus. I didn't mean times. This is a plus. I have 4 of them. Okay, thank you. Here's another way of thinking about it. Thank you. Here's another way of thinking about it, okay? Let me just write this same problem again. And this is how I think is easier, right? Just think of it, instead of root 5, think of it as boxes. I have 1 box, and then I have 3 boxes, right? 1 box plus 3 box gives me how many boxes?
4.
4 of them. For some reason, when we add that radical or that root in there, it gets confused in our brains. It's just like too many numbers, right? But if I say to you, hey, give me 3 of these. Oh, now give me another one. Well, that's simple. How many did you give me? 4.
4.
That was real simple, right? But when we say radical 5 plus 3 radical 5, all of a sudden it's all these numbers and they start getting all jumbled in our brain and we get all confused. But the fact is, we have 1 of something, we're adding 3 more of something. Now I have 4 of them. Okay? Yeah, the answer is, well, 4 of what? 4 of those root 5s. That's the answer. Okay?
So we only add the outside.
Yes. Yes. You only add the outside numbers. Okay? If I had root 5 plus 3 root 2, I cannot add those. They're not like terms. I can't add them. Just think about it, right? Let's just say that Zanai just gave me 1 pink slip, right? And then Ronnie gave me 3 doggies. Can I add the 3 doggies and the 1 pink slip? No, you can't. They're totally different. Okay? Now, Zanai gave me 1 pink slip and then Ronnie gave me 3 pink slips. Now I have 4 pink slips. Okay? They have to be the same thing. They have to be like terms. You cannot add them if they're not like terms. So we would leave that exactly the way it is. We can't simplify that. Okay? Okay, what if I have 3 root 7 minus 2 root 7? What's that going to equal? 1 root 7. Right?
The 1 in front?
No. Yeah, you can just put root 7. Okay. Okay, huh? Yeah. So if I have 3 root 7 and I subtract 5 root 7, right? All we're doing is doing the numbers in front. 3 minus 5, negative 2 root 7. Okay. Questions on that?
Can you do one of like you were saying? We can't like add if they're not like terms.
Yeah.
Like
Okay, so let's do this one. Let's do 2 root 5 minus 3 root 6 plus 7 root 5. Okay. Which ones are like terms? The 2 root 5 and the 7 root 5. What do they add up to? 9 root 5. So I have 9 root 5 minus 3 root 6, and that's our answer. Okay? Okay, it gets a little bit more complicated. Let's do 3 root 2 plus 4 root 18. So at first glance, that does not look like it's like terms. So at first glance, it looks like we can't do anything. But we always want to make sure everything is simplified before we make that decision. So the 3 root 2, that's definitely simplified. But this one is not. Because the 18 can be rewritten as 9 times 2. So this is 4 root 9 times 2. What can I do from there? Take that square root of 9 out, which is a 3. So now I have 3 root 2 plus 4 times 3 root 2. Okay. Which gives me 3 root 2 plus 12 root 2. Now I see, oh, they are like terms. We always multiply everything that comes outside. So now I can combine them, and this is 15 root 2. So when we first looked at it, it looked like they weren't like terms. So it looked like we couldn't do anything. In reality, we could. So you always want to make sure everything is fully simplified before you decide whether you can add or subtract. Okay. Here's another example. Let's do 2 root 75 minus 3 root 27. Okay. So 75 and 27 are not simplified, right? Okay. So let's go ahead and simplify those. So this is 275. I can write that as 3 times 25. And 27, we know that's 3 times 9. Okay, and just to make sure that no one gets confused, we're going to write this out even further. I know some of you can see right away that we can do something out, but let's just write it out further. Okay, so we take our pairs out. So here we're going to take the 5s out, and this becomes what? Right, so that would be 10 root 3 minus, and here we can take the 3s out, and that becomes 9 root 3. So what do we get as a final answer? Root 3. Okay. What do you think? Not too bad? It's actually kind of easier than the division, isn't it? Division gets kind of confusing. Okay, let's do a worksheet. Okay. Okay, everybody's iPad is away. Okay, so number one, I have 2 root 6s, and I take 2 root 6s away, so what am I left with? 0. Boom! That was an easy one, right?
Wait, but how is it 0 if you said we don't take, like, we only do the outside?
Okay, good question. So, I'm going to give you 2 of my Eagles papers. There's 1, and there's 2. I just gave you 2 of those papers. Those are root 6s. Okay? Now I just took 2 away. How many root 6s are you left with?
9.
There you go.
So,
You had 2 5.
Okay, let me show you. Look, right? So let's pretend, for argument's sake for right now, that I had 5 root 6 minus 2 root 6. What would that equal? Okay, and 3 root 6, right? What is the mathematical operation that's going on right there between the 3 and the root 6? Multiplication. This is 3 times root 6. That means I have 3 of those root 6s, right? So here we get 0 root 6. Do you agree with that? 2 minus 2 is 0. Well, this is 0 times root 6. What is 0 times anything? 0. So there's my 0. Okay? Okay, let's look at number 2. So they're not like terms, are they? So I can't add them the way they are. However, we can simplify. So how can we simplify the 8? We're going to write it as 4 times 2. Okay. And then what's the square root of 2? 2. So we're going to take that out. So we get 2 times 2 out there, which means I have 4 root 2 plus 3 root 2, which gives us 7 root 2. Okay. Good so far?
Yeah.
Okay. All right. What are we going to do with this one?
Split 9 and 6.
Okay, so we get negative root 6 minus, we're going to split this up to 9 times 6, which does what?
So you can also simplify them.
Bring the 9 out. Okay, so the square root of 9 is 3. Okay, which gives me
Negative 4 6.
negative 4 root 6. Kind of fun, aren't they? Stop me if you have questions. Okay, number 4. Tony, what do I do? Yeah, let's simplify the 18. So we have 2 root 2 plus 2. How did you simplify it? 6 and 3? Okay. And then what? Good. Yeah, let's break the 6 down to 2 times 3 times 3. There you go. There's a pair. We're going to bring them out. Anything that's outside, we're going to combine. So that becomes 2 times 3, which is 6. Okay. And now we can add them, right? Excellent. Questions on that one? Okay. Next one, Jonah, what you do? Okay. How are we simplifying the 24?
6 and 4.
Okay. 6 times 4. So we're going to take the square root of 4. That's 2. So we have 2 root 6 plus 2 times 2 root 6. So that's 2 root 6 plus 4 root 6, which equals 6 root 6. Okay. All right, Allie, yes?
Oh, I see. Wait. Okay. I guess it's I simplified the 18.
Okay, to what?
I did 9
9 and 2? Okay.
and the 9 simplifies to 2 times 3.
Okay.
And then I can take the
So we'll take the 3 out. Good. And that becomes 6. Can we do anything with the 3 root 6? No. Okay. So then looking at this one, these are my like terms right here. There you go. Excellent. Okay. Okay, Ava, how about number 7?
Yeah, so simplify 27 to 24.
Good. And how did you simplify the 27?
9 and 3.
Okay. And the 24?
8 and 3.
Okay. So let's see here. When we simplify this, what happens?
I get 3.
Okay, so then we bring that 3 out. And we have 6 outside there, right? Okay, how about this one, the 8 and 3? Okay, so does anyone see a way we could simplify that tonight?
4 and 2.
Yeah, the 8 is 4 times 2, and we know the square root of 4. So we're going to do 2 root 3 minus 6 root 3 minus 2 root 6. The 2 and the 3 are left inside. So now we have like terms right here. So minus 2 minus 6 gives us minus 8 root 3 minus 2 root 6. And we're done. Yes, ma'am.
So even though we don't have like an outside number, then we're able to still simplify because you.
Mm-hmm.
Okay.
Yeah, you want to make sure you do simplify even if you can't combine it with anything.
Okay.
Okay. Okay, so looking at number 8, this one's kind of nice because I don't really have any simplifying to do. Everything is already simplified. So here's my like terms right here. So negative 3 root 5 plus 2 root 5. Caroline, what's that going to give us?
Negative root 5.
Good. Negative root 5, and then minus root 6, and we're done. Okay. Okay, Hunter, how about number 9?
I did the 27 with 9 and 3.
Good. Oh, I'm so proud of you guys. You're doing great. 9 times 3. Okay.
And then the 9 with 3 and 3.
Good. Okay. And then what?
Bring that pair outside.
Right? Okay. So we have 3 root 5 plus, now when I bring that 3 out there, 3 times 3, so that's 9 root 3 plus 2 root 3. Okay, now what?
Simplify. Add your root terms.
Okay. So we get 11 root 3. Very good. Excellent. Okay. All right, Kaya. How about number 10?
Simplify is 27.
Yeah. Let's do that.
Just set it up for it.
I actually didn't simplify it. It's not wrong, but it's going to make a little extra work. Do you know why? Because these are actually like terms already, even though they're not simplified. And the only reason I'm not going to simplify them is because they're going to completely cancel out. I have minus 3 and I have plus 3. If these were not going to cancel out, I'd go ahead and simplify it and then work with it. But they're going to completely drop out of the entire thing. So I'm just left with 3 root 3. It's not wrong if you simplified it, because after you simplify it, they're still going to cancel out. It's just a lot more work. Okay? All right, any questions for me? Okay. Monday, I will give you a review worksheet to review for the test that we'll have on Tuesday.